we objects of all this attention that we lavish on students and see what the actual consequences of this attention are. Mostly what we're going to do this morning is take questions from you, but first of all, we're going to go through some introductions, and here's what the format's going to be. We're going to answer each of the students will answer 2 questions, and then we're going to open up the floor to you. They've been giving their marching instructions that they have very limited time in which to answer these questions, so I think we can move through this quickly, but this way you'll have a sense of who they are and can sort of direct your questions to the most appropriate person. So what I'm going to do is introduce each student, and then they're going to answer a question. Then I'll introduce the next student, they'll answer a question. Then we're all going to answer one other question. And the 2 questions we're going to answer at the beginning sort of fall into the categories of cause and effect. The first thing I'm going to ask them to do is just to tell me about one or maybe 1 or 2 factors that got them interested in extracurricular mathematics, math circles, math competitions. The second round of questions is going to deal with the consequences of their involvement in those activities. So we're going to go down the line this way. The first student we'll hear from is Maksim Maydanskiy, who grew up in Kiev. He really wasn't involved in math competitions until the 8th grade when a teacher got him interested in that. Shortly before he was supposed to graduate from high school in Kiev, he moved to the United States, to San Francisco. Did another year of high school while going to the Berkeley Math Circle and participating in competitions here in this region. Went to Berkeley as an undergraduate while continuing to work for the Math Circle, and now is a first-year graduate student at MIT with an interest in geometry. So again, 4 minutes maximum for each person to say a little bit about how they got involved in math circles.
Thank you, Steve. So as you heard from the introduction, oh yes, that would be a good idea. My interest in mathematics sort of started almost accidentally. I was in a regular elementary school and middle school, and I was doing well in my classes, but nothing special was going on. And then at some point, my parents moved me to a different school, and then there was a key figure, one teacher that really started me on mathematics, gave me problems, started, explain to me that there is this world out there with the Olympiads and the competitions to go to and do all of that. And it seems to me that if there's one point that I want to make is that all of my short so far mathematical career has been guided by key figures. There's been these 2 or 3 people that really got me into it. And there were the Efim Mikhailovich Rabinovich, the teacher in Ukraine, Zvezda, and then later on Joe Gallion, who's in the audience too. So really the only point is that there were no big sort of, these people obviously were part of some frameworks, but for me, on my personal level, the context were, really the key figures that did it for me. So that's the story.
Okay, our second panelist is Igor Gachkov, who grew up in Kazakhstan and also got interested in this kind of mathematics in the 8th grade. That sort of seems to be a bit of a theme there. Was on the IMO for 3 years, and in fact, the year I wrote about the IMO, the team from Kazakhstan finished 6th. There were 4 members of that team who received gold medals, which was quite a surprise, including Igor. He came to MIT, is now studying computer sciences and mathematics, and says that he's taught math Olympiad preparation camps in Kazakhstan and now is teaching at a math Olympiad preparation course in Connecticut.
So I'll try to put my story very short. I got into Kazakh-Turkish high school in my hometown in Kazakhstan, and there is about 30 of these high schools in Kazakhstan, and I didn't have any particular interest in mathematics. And after finishing 7th grade, there was among all these 30 high schools, there was a training camp in all the, in math, physics, biology, chemistry, and the teachers just said, if you want, just go see what's there. And I went and I met a lot of people, students who were smaller than me, bigger than me, and they were still doing much better. And I always thought that I'm good in mathematics, but they just completely swiped me in, and I started to study hard, and I got interested by some books. There was particularly one book which was written for 6th graders, and I was in 8th and I didn't understand anything in it at first. So I was really frustrated, and as someone put it yesterday, mathematics is 99% of frustration. So that's basically frustration got me into mathematics. That's my story.
The third person is Melanie Wood. I met Melanie at the MOP in the year 2000 when I went out to Nebraska to see whether it was even possible to write a book about these kids. The year before I actually did it. She was a student at MOP in 96 through 99, and then has been involved in MOP in various ways since then. I might say that the favorite chapter of my book is based on Melanie, because she really does have an incredible story before she got to MOP. But I'm just going to cover what happened afterwards. She was an undergraduate at Duke, then went to Cambridge, where she came in top on the Part 3 mathematics exam. I'm not familiar with that, but is now at Princeton working on a PhD in algebraic number theory, and also won the Morgan Prize for undergraduate research last year.
The first thing that really got me into mathematics was doing the math counts competition, and then that just led me into a series of more things. After that, it was natural to take the AMC tests, and once I was linked into the network, it was very easy to find out about all the opportunities. And for me, math counts was the key link into that network. An extremely important thing throughout all of this was the availability of other students that I could talk to. That was the best thing about math counts for me, was all of a sudden I met all of these students who could do math at the level I could, and then of course the same thing again at the Math Olympiad program. I even changed high schools and went all the way across town to go to a different high school, because there was going to be one other student in Indianapolis who was doing math at my level, and he was going to be at a high school all the way across town, and so we went through a big rigmarole to go to that high school, so I would have one other student that I could work with, and so that's obviously why I think all these math circle kind of things are very important, to get people those connections to other students.
I also met Ina Zakharevich at MOP. She was there in the years 2001 and 2002. Is now an undergraduate at Harvard, doing a double major in mathematics and computer science. Are my notes right about that? Okay, good.
Well, I suppose I could say I've always been doing math. My family has at least 3 mathematicians in it, and it's always, math is beautiful. You don't need me to tell you that. But I suppose that when I really got excited by math was when I met 2 people at a summer camp that I went to. And they weren't at the summer camp. They were giving the last guest lecture at the summer camp on Olympiad problems. And I'd seen Olympiad problems before, and I found them interesting, but I wasn't inspired. I think what I was inspired by was the fact that these people were so passionate about it and were actually in the middle of doing it. And it didn't feel like they were trying to get me to do it. They were just naturally passionate about it, and they were in the middle of it, and they were doing it. And I became friends with them, and I sort of got pulled in with them, and I became passionate about it. And yeah, and I had access to this whole network. I went to Berkeley Math Circle. Josh Zucker was my 9th grade math teacher, and he really helped me because he showed me how beautiful math could be. And I had books recommended to me, but really what helped me was meeting these 2 students who were so passionate about it that they could get everybody around them passionate about it too, just sort of by osmosis. What are their names? Oznier and Andrew Dudzik? I mean, a lot of you will know at least about them.
Our 5th person is Fu Liu, who started to take classes for math competitions in the 4th grade in China. In her 2nd year at high school, she got 1st place in her city in a national math competition, was selected to participate in the Chinese Mathematical Olympiad, where she got 2nd prize, was one of the 6 members of the Chinese team to the 37th IMO. And I need to ask her where that was, the 37th IMO? India, okay. Which people tell me was extremely hot. That's what I've heard about that one. She's currently a math graduate student at MIT.
So different one, my interest in math is not because of my family. So I remember whenever I told someone that my father is a teacher in high school, so they will ask, "Oh, so he's teaching math?" But I said, "No, he's teaching politics." So I started I think whenever I start my school, I always feel I'm interested in math, and in my fourth grade, I saw this poster saying there's a um problem solving class outside of my school. So I thought it's a good idea for me to like take that class. So ever since then I started my math competition career. So I started to took math competition since my fifth grade, and because of that, I went to my middle school without exams. Um, and in my class, there were a lot of people doing math competitions. So I think that's one influence make me like continuing doing that. Because if you have a group of people around you and doing like similar thing, and it will encourage you to continue to do that. And for the same reason, I went to my high school, and there's this special class for science students doing science. So most of the classmates I have, they are doing kind of science competitions like maths and physics and chemistry. So I feel like I'm always in this kind of s- um, um, circumstance that have people around me to doing similar thing as I do. So I think that's the factors I'm doing math competition. Okay, thank you.
So we're going to do one more round of questions before we take your questions. And we had a bit of email conversation about what this second question should be. We decided we would talk about what the effects of the involvement of these students in these activities was, but we couldn't decide if we should discuss whether it should be the effects inside mathematics or outside mathematics, and whether we should talk about positive effects of these experiences or negative effects, to the extent that there are some. So in the end, I just said, well, pick something interesting and tell us about it. And so that's what their directions have been. We'll just go right down the line.
With that in mind, so really, I'm in the position of saying the obvious again, but outside of the mathematical competition and all of these, development network, I don't think I would actually be in mathematics. So the whole of my, experience for the last maybe 10 years has been actually formed by the initial start that I got in math. And I mean, look at me here. I'm a graduate student in mathematics. What else do you want? Also, so academically, it's all there is. Well, almost all there is. But also socially, it's been it made quite a difference, because I realized that now a significant portion of my friends are actually people who did math Olympiads with me back in say in Ukraine, and some people who who did say ARMO later in San Francisco. So the apart from academically shaping the career, it also changed the circle of people I associate with. Basically, it changed the whole life, I guess. I mean, that's just to say it shortly.
Okay, so I mean, the biggest effect is that I probably got into MIT from Kazakhstan. And besides that, I think that the best part for me was actually the social life in math competition. And I think competition is the defining word here, and math comes after that. Math, like in university and in graduate student, you're doing really math, but in competition, you're competing, and it has its own like rules, and you get to go to different places. You meet too many people. You have like friends with whom you, I don't know, struggle, go to the exam, and come out and celebrate. And besides that, I met like a lot of people who did other kinds of Olympiads, and I learned a lot from them, like of the opportunities, and I think it just broadened my like outlook at the world in general. Yeah, that's about it.
Well, first of all, I think that the biggest benefit that my involvement in math competitions has had for me is actually mathematically in the amount of mathematics I know. I mean, people say that we just teach these kind of side topics and tricks and techniques, but the Math Olympiad program is where I learned linear algebra, which I think most people would say is important. It's where I learned elementary number theory, which made me far better prepared to go into an abstract algebra class than most students going into abstract algebra without having seen the wonderful class of examples that number theory provides. I mean, I got, even my first beginnings into algebraic geometry from Karan and Zvezda in classes. They taught a mop for things we used from things we use for actual geometry problems, a mop to just extra enrichment that Zvezda taught sometimes. And, that's all been incredibly important. All of the time, things come up in mathematics, and I think, oh, the first time this is as a graduate student in mathematics, and I realized the first time I learned about this was at MOP. My boyfriend's a graduate student in combinatorics, and the things that they have to teach students in combinatorics, we teach students at MOP. But if they didn't go to MOP, they go through college without having a combinatorics class, and they have to start at, day one in graduate school, where we start with our 9th and 10th graders at MOP, teaching them combinatorics techniques. And so there's a lot of math that I actually got through this, and that's been the biggest benefit. The biggest downside, it's, not, of course, a reason not to do it, but there's a lot of prejudice, I think, in the real math world and the research math world against competitions and people who did competitions. At Princeton, where I'm a graduate student, I taught a Putnam preparation class this fall, and a lot of the faculty thought that was a bad thing, a waste of my time, that undergraduates shouldn't be doing this, they should be doing real math. I've encountered a lot of situations where people assume if you have two students with similar records except one did competitions, the competition student is probably going to be not as good at research math because they can only do competitions. That's absolutely ridiculous. And it's not the competitions are the only way to signal if people are going to be good at research math, but there's certainly a strong correlation. People are worried that students who do competitions can only spend 5 hours on a problem and they give up. But people who haven't done competitions have probably never done a problem that took them more than 10 or 20 minutes before they get into college. And so I keep encountering all of these stereotypes that the rest of the research math community has about us. And I know that you guys all know that they aren't true, but it's important to realize that we're up against this, and this is a big problem, and we really need to convince the rest of the world. But we know that these math circles and math Olympiads are the perfect stepping stone from regular school mathematics into a bigger world of mathematics. But most people in professional math, seem to have a lot of trouble with that idea.
I would have to say that the biggest benefit I've gotten out of competitions is the idea that a proof should be beautiful and simple, that it shouldn't have to involve a lot of computation, it shouldn't have to be long and tedious and go into a lot of high-powered theorems in order to prove something, that you can prove very important things very beautifully and simply, and that you should strive for that. But also, it's changed the way that I look at how to explain things. I do a lot of tutoring and course assisting, and when somebody is having a problem, a difficulty understanding a concept, generally the first way I think to explain it is to think of a competition type problem that uses similar ideas and to give it as an example for that. I mean, for people who are having trouble with algorithms for graph theory, I generally start giving, problems about people knowing each other. And just the way that I look at problems tends to be, explaining problems tends to be from a competition standpoint, rather than trying to rephrase the theorem or trying to work out examples with it. It's more give a problem and show how to solve it using this theorem.
I don't have much to say about what the consequences. I think the most important one for me is that because of my good performance on the competitions, so I didn't have to do all the coursework in my high school. Then you can say it's a positive or negative consequence, but that way I have more time to think of what kind of thing I like to do, and I have more choices. Like for instance, I have more choices on university which I want to go, so I can choose the one I really want to, and I can think of which subject I want to major in before I was admitted by universities. Because usually students in China they have to work hard on exams for admission for universities, because the competition is very competitive. But I don't have this strength, so I can like think a lot in my high school. So I decided to go to my first university, Peking University, and then after I entering my Peking University, then I met some friend who told me that I can choose transferring to some university in the U.S. And I think I got the admission from Caltech because of the IMO, and I got bronze medal in IMO. I think that's and I was really enjoying the experience I was at Caltech. So I think that's the most important consequences I have for this. Thank you.
Okay, now it's your turn. For the purposes of the web, I'm going to hand people who ask questions this microphone and just ask that you could ask the question into the microphone. So feel free, whoever. Our first question.
Hi, I have two questions for all of you. One is, what were the first times that you were thinking about questions on your own that you kept thinking about for a long time? That is sort of topics of continuing research of your own. When I was a kid, there were Ackermann's function things, and there were, and some of you probably, if you just stumbled on some interesting thing and kept exploring it, that's an important thing. And I wondered whether that also played a major role along with the competitions. The other question, especially for Fu, did you run into, do any of you play Go? Do Wei Chi? Wei Chi. Thank you.
I'm not going to have everyone answer these questions, so I'm going to have them sort of volunteer. But I'm going to volunteer somebody first to answer the first question, because there's a great story that I tell about Melanie in my book, which I hope will be her response to this question about working on problems on your own. So that's your experience in kindergarten.
Oh gosh. Oh, when okay. I'm not sure. I guess I now know what story you're talking about, and I'm not sure if it exactly answers the question, but I guess one of my first explorations into kind of research math, you might have called it. It wasn't original, of course, but I didn't know that at the time, I suppose, was when I was very little, I guess, in kindergarten or maybe earlier. My mom, when we were on errands, to amuse me, would give me equations to solve, like you'd start and I was like x plus 2 equals 5 or something. And this was how I discovered things like negative numbers and fractions. because all of a sudden I would have equations that I couldn't make sense of, and then discovered that we had these other things, and of course my mom's there and could help me along. So I think that was, I don't know. Oh gosh, I'm sorry. We have to hear another story from my childhood. Oh my gosh. Okay. Well, in kindergarten I got in trouble for using these flashcards that had the numbers from 1 to 10 on them. I was sorting them into odd and even numbers, and I discovered that, like, if you added up 2 odd numbers, you always got an even number, and if you added an odd and an even number, you got an odd number, and so forth. And for the first time, I discovered all of this, this structure, which I now, like, looking back, think, oh, I was quite a little genius, but. Anyway, the punchline, I guess, is that I got in trouble because they were like the numbers from 1 to 10, and I was supposed to be studying larger numbers because I had already passed that test or something. Anyway, and I've never played Go. It looks extremely complicated. So.
Anybody else on this one? So this is when you first started thinking about math in a sustained way. No? And any Go responses? Not even from Fu. Okay. Here. Are you going to say, oh, you can't do it? Oh, okay.
So, as far as I know, so my, the 6 members on my IMO team, I only know one person playing Go, but my team leader does play Go, and I think he's pretty good at it. And actually, when I was answering the question of the second question, I was going to say that the one thing I learned from in the math circle was playing cards, because all the people there are playing cards instead of playing Go. So I don't know why, but I guess because it's easy.
Bob, did you want to? We'll go over in the corner and then go around.
Melanie mentioned the stereotypes that the research mathematicians in particular had against people who do competitions. I was curious about your reactions to what maybe some of the general populace stereotypes have been about young people who like to do mathematics. We saw a cartoon yesterday that I'm sure the cartoonist thought was funny, but I don't think the cartoonist missed a single offensive stereotype about people who enjoy doing mathematics. I think the person got a clean sweep. I was curious about, in your lives, how that's affected you, whether there were any times when maybe you thought that this was something you didn't want to do, because there are some people out there, we hope not too many, but some people who have those stereotypes, and what perhaps advice you would give to other young people who might want to do this but might be deterred by those stereotypes.
I actually didn't met almost any people who had that stereotype, and I kind of had this stereotype myself before. But again, when I met a lot of people, like at that first training camp, they were all just like normal boys. Like some of them, like I don't know, were joking half of the time. Some of them were playing computer games half of the time, and they were still doing great math. So I think like people should just know that you can combine a lot of this together without them being okay. Thank you.
Well, it is a sort of an inconvenience sometimes socially when you meet somebody and they ask you what you do. I'm sure you all are aware of this fact, and then they ask you, well, sometimes they just go, oh, and sometimes they try to ask you to explain it to them, and you try to make something, but it's slightly difficult, and sort of in the greater world, there is a preconception. I realize it's there, but I've been fortunate enough that most of the time it's like, oh, you don't look like a mathematician, in a sort of a positive way, but So there is that, of course, but I personally find that, in fact, it's completely opposite. And if there are young people, they should know that mathematicians, I find, maybe I'm biased, perhaps, are one of the most exciting crowds you could ever find. In fact, so go out there and seek out the people who like math, and you'll see how wonderful it is. So that's basic message. I don't know.
Man, I wish I had some answers to the problem. I want to say that I think it's a problem. I mean, the kind of people at, in my schools that hung with the nerdy kind of crowd that would have fit the math stereotype were all guys. They all spent most of their time playing Dungeons and Dragons and doing all sorts of things that I had no interest in doing. And it was hard. I did a lot of other things. I did theater, I was a cheerleader, I was student council president, I did all of that stuff, and so I feel like that was what made me be able to have a normal social life and have friends through other things. I don't know what to do because I see constantly girls being discouraged from doing math because they can't, they don't have a social circle, to do it. And we even saw from it worked out when she found some friends that she liked. Even if they don't have to be girls, but they have to be people that they can relate to. I think this is a huge problem. I don't know what we can do except maybe try to get people when they're younger. That's my best guess. Get at them when they're second, third grade or something before they have too many stereotypes.
I suppose the only thing I want to add is my friends were the people who were playing Dungeons and Dragons and were the thing, and none of them did math. All the people I knew who did math were also the people who were in choir and who did some kind of sport, and that was mainly the reason I wasn't friends with them, because they weren't interested in the same things I was interested in. So it was when I got to know people who did math that all my interests broadened past, reading fantasy books and playing computer games.
And actually, I want to stay on this question for just 1 second and ask Fu, who hasn't responded, about whether these stereotypes are the same in China or the extent to which they might be different there.
I think I did met this kind of people who's doing math, and but I don't think most of people in math are like this kind of thing. But I think the situation in China is probably different from the U.S. because, as I said before, the competition is much intensive. So everyone has to work hard. So which makes people who's like good at math or some other science, they probably cannot have much time on like gaming or some other things. So it's possible they look more nerdy than other people's. So that's what I want to say.
Thanks. We had, let's see, we're going to go back here to Paul.
Thank you. So I want to get back to this issue of consequences of competition and just the nature of competition, whether it's good or bad. So, because you are an unusual sample in that you are winners at competition. And so you're saying that it's been good for you, and I can agree. But I worked at the Math Olympiad program for several years. I remember Melanie when she was an 8th grader and doing very well. And I remember one of the hard things about my job at MOP was that I was working at a job where there would be kids with an IQ of 175 who would be feeling humiliated and stupid, and I'd have to try to keep their ego up. And so my question to you is, what about the losers? And when I say losers, I mean people who are engaging at a high level of math competition, but just kind of not doing that well, sort of people who are coming close to, washing out in some way. You know some of these people. How do you think competition do you think competition, does it hurt people who are struggling, or do you think those people also find a way to love mathematics?
Well, on the first 5 tests that I did at MOP, out of the 5 times 2100 and 5 points that are available, I think I got 5. something like that. And I wasn't very happy about it. And I have to say that at first it made me feel really stupid. And I was like, okay, I can't do this. I'm just much stupider than everybody else here. But then what I realized is that I don't really care if I'm doing significantly worse than everybody else, because what I'm interested in is the problems. I'd like to know how to do them. And, if it takes me 5 more years than everybody else to learn how to do them, well, that's okay, because I'm interested in knowing how to do the problems, not knowing how to do them faster than everybody else. And that's probably sort of the best realization that MOP gave me, because, you want to care about the math. You don't want to care about the fact that you're doing the math better than somebody else. And I'm a very competitive person, but I have to say that probably not doing that well helped me more than doing well immediately would have, because I never would have learned that it's not winning. In math, eventually you don't end up winning, you end up just learning, and you want to know that learning is the more important part.
And do you think you're representative, or are you unusual?
I don't know. I haven't talked to everybody who doesn't do well on math competitions.
Anybody else who wanted to say something there? So we'll go that way.
Yeah. So I was in this special class which like every people in doing science competitions. So I didn't know before, but recently I saw some people like we have like a room in a BBS thing, so people can talk on the web. I saw some classmates of mine said that the experience of her in high school was not so great because of there are so many great people around, so she didn't feel good in the class. And so at that time I realized that I think it's not like being a such competitive group. It's not everyone feeling good about that. But I think the way I think of this is that because I don't think everyone can be successful all the time in his life. So maybe being a loser when you are young, it's not that a bad idea, because you can learn how to like you can learn that you cannot be always successful. So I think if when people is always successful when he was young and suddenly got lost in like when in like 30 something, and it's hard to recover by that time at that time. So I don't think so I think being loser or successor for people is either way it's a good experience for like doing competitions. That's what
So
I
yeah,
feel.
let's do one more response to this question, then we'll move on. Okay.
So I was quickly trying to catalog a lot of the moppers that I know that kind of washed out of mathematics, and I think a lot of them were people who weren't very interested in math coming in. They just happened to do well, and that the people who liked math coming in, for the most part, did fine going out. I think actually the bigger problems I hear are from people who say didn't make MOP. I know a lot of people in colleges who are math majors and who, because they didn't do well, in particular on the AMC series of tests, decided that they weren't very good at mathematics. They must not be good at it, and I think that's a big problem because there's not much else out there in high school for them to grab a hold to except some of these competition results. And some of these people now, a few of them have made it over it and are very doing good math now, but some of them are people who are in other fields who might have been great mathematicians but decided back in high school, they weren't one of the good people because they never made the USMO or MOP or something.
Actually, I've changed my mind. This is such an interesting question that I'm going to have the other two people do it too.
Well, yes, there's certainly something to be said to the point that Laney was making, and I think Kolmogorov said at one point that if there were math competitions in his time, he would never become a mathematician. But also the point of egos and sort of gauging it. I think at some point, I came to a conclusion that unless you're, Witten or Wiles or one of the other dozen, there's always going to be somebody who's going to be smarter than you, and the point is that you should. in some sense, understand that and realize that this is what's going to happen, and it might even be better than when you realize it earlier on than later on, and so competitions are doing something in that sense, that they're showing people that I mean, yes, you might be best in your classroom, but you're not necessarily the best in the world, but that's okay, because except for one person, everybody else is not the best. And this has been, of course, a personal experience as well. I mean, I've been doing well in the competitions, but there are people doing much better all the time. The problem, of course, is, as has been said, is that the gauge that the competitions provide is not necessarily the gauge that that corresponds most accurately to the research potential or whatever else, and it might preclude other people. But I don't think there is a problem intrinsically with just sort of sorting out people in some sense.
So I had a lot of friends in my high school who was also doing math, but for example, one of them entered the regional competition 4 times, and 4 times he was fourth. He still went to maths to university, and he's doing pretty well, I think. And what I wanted to add is doing math competition is a good investment of time, whether you succeeded or not. Like, even if you go out of math and start doing something else, you still have a very developed way of thinking about problems, like how you first understand it, play with it, then you do some conjectures, then you try to prove it, and so on. So, and besides that, in Kazakhstan, there is like not so many things that the YAS can do. So doing math is particularly useful investment of time. Okay.
There were a couple of early questions back here. So since they had their hands raised first, I'm going to go back in this direction.
So this question is addressed for those of you on the panel who have started graduate school. So you've had some experience with the transition from doing contest problems to doing, quote, real math, end quote. The question is phrased from personal experience. As somebody who made this transition and found it quite difficult, and found that it was sort of unexpectedly difficult how much of a transition there was between doing the little self-contained contest problems and then working at the level of research mathematics. I want to know, did you sort of feel these sort of difficulties? B, is there anything that that helped you get past them? Or C, is there anything that in retrospect would have helped you get past them?
Melanie, you've already said some things about this. Do you want to say anything more, or?
I guess I'll say.
Okay.
I think my experience was actually, I always thought about contest problems in maybe a way that wasn't perfectly advantageous for the contest, but more like how it makes sense to think about research math problems. I think it slowed me down on competitions, but for me the transition was very easy. That's what I wanted. I wanted to be able to not have to just solve that particular problem, but to find out what was interesting, in general out there. And so, I mean, of course, I guess it's tricky, because the thing that would help that would be to teach students more to think in that way, but that's just going to hurt the competition scores, so it's hard to say.
I don't know. I'm really just starting on this whole research thing, so I'm going through this transition, as you were saying. But I actually find that despite the difference in a sort of quality of reasoning that goes on, the basics of the very basics, for example, how to structure a proof, how to read the mathematical paper, how to follow an argument and produce an argument are essentially the same. So in some very, very fundamental sense, competitions were the groundwork that led to all of this stuff. And in terms of tackling longer and harder problems, well, it is true that there is significant differences, but in some sense, it's all mathematics. It's all the same fabrics, same style of reasoning, and I think that's fundamental. Of course, I mean, I already mentioned that an RU program that Joe organized was very instrumental in sort of easing the transition and not making it a hard break, but sort of a little softer when you go and you work on something for 6-10 weeks, and then later on you move on to research problems. It makes for a softer landing, I guess.
One more early question back here, and then we'll move back up here. So, Karan, can you still have one?
Thanks. I kind of thought that I was already done. No. Okay. So, a quick, short comment on what Igor Gachkov mentioned like half an hour ago, that I just wanted to expand the point, that basically mathematical competitions, and that should also answer some questions, I think, what Paul asked too, that mathematical competitions for the last years, I think, played also the role of like kind of a social network, social outlet for the people, you know, who are interested in math, and they're stuck somewhere and they don't know who to talk to, and they don't want to talk about some stupid stuff to their classmates, and they think it's stupid. Well, not necessarily. And there's nowhere to turn, and so this is kind of a social support network that math competitions sometimes provide for a lot of people like that. And so for 90% of those who don't succeed, really go to IMO or win the first prizes, this thing is sometimes even more important than, you know, winning the competitions or being really extremely good at math. They just want to come there to talk about stuff that interests them, you know, even if might be not on the 100% level of the other guys, you know, but they still, you know, feel that that's something that they should do, that they're interested in. Okay, so my question then, I think it's mostly for Melanie, because I kind of suspect the answers from the other guys. I suspect I know them, so. And Melanie, you know, being from Indianapolis, right? Right, so it's kind of like a real American experience, whatever, growing up. So the question is, could you tell us how it was, I mean, or I'm sure you know how it is right now, how easy it is for the school kid who thinks that he's interested in math and, I don't know, 5th grade, 7th grade, or his parents want him or her to, you know, to go and study something like that. How well do they know what to do? How good is the coverage, basically? How good is the information level? You know, do they immediately, oh yeah, sure, I know, I saw all those advertisements on TV all the time. Every 10 minutes they go to math counts, or, you know, apply to this school, or there is this teacher. You know, well, I'm exaggerating, of course, but this is basically the question. You understand me, I'm sure.
So while I'm walking up here, I'll say that I did a little informal survey before I came out here of the middle schools in the Montgomery County public school system where my kids go, reputed to be one of the best school systems in the country. And about half of the middle schools have math teams at the beginning of the year, and by the end of the year, it's about a third. And so these kids, you've got to be lucky to have an opportunity to do it, even in a place like that.
In Indiana, you have two chances. If you live in Terre Haute in the Honey Creek School District, you have Bob Fisher as a middle school math teacher. And your second chance is to make the Indiana Math Counts team and be in the top 4, where Bob Fisher will be the state coach to Math Counts. Though that's it. If you don't do that, you don't have a chance. It's particularly poor, especially since the Math Counts entry fees have raised. I don't know how many of you know about this. While the number of teams participating in Math Counts has gone up a lot with the new rules, the number of schools participating has dropped tremendously, and unless they do something funding-wise, will probably never be at the level it was when even I was in middle school. So yeah, in Indiana, you have, you know, it's very hard to even be at a school that has a Math Count